member of. Okay, let me share screen. I believe everyone's seen my screen, correct?
Yeah, correct.
Okay, let me remove this one. Okay, I wish let's see. I'm trying to understand team. In our college, we still have a team, but let's see if I can only share the window. Okay, this one is good. Yes, I believe now we are good. Okay, so thank you, Kako-sama, and everyone, and Dr. Bōtə, and everyone involved in making this. It's really honored to be here and speaking to you all. I'm not sure how many of you don't understand Kurdish, but I wish in future when I'm doing this, mostly I speak Kurdish. So maybe sometime I get excited, I turn to Kurdish, it's just because I like to do this too. So today's talk is about Islamic geometric pattern. I have been giving a talk to Islamic geometric patterns since 2016. Even my research area is not this. My research area, as Dr. Kako-sama said, is ring theory. Let's do this. So first, I want to say, how did I found about Islamic geometric pattern? So I born and raised in Kurdistan. I'm originally from Suleymaniye, but I finished my master's degree in Erbil. So a lot of my life have been in Erbil. And it surprised me how I live in a Muslim country and I never been aware of this beauty, this mathematical beauty around us. So what I'm hoping for is by the end of the day, you appreciate something that you can see daily in your daily life. So I found about Islamic geometric pattern by accident when I was looking at some posts in Instagram, and I looked at those artists, they creating this this beautiful painting, drawing, and that basically they using a compass and straight edges. And I asked myself, I never consider myself doing anything to art. So I told myself, this is maybe my chance to get involved into creating some drawing. While I was starting drawing and I was sharing with my friend, and then start people noticing and asking me if I want to do more to them and share my experience. And this is what I do from 2016. Starting from 2016, I started to doing a lot of math outreach. I participated in a lot of math conference in US. Some of them are regional, like a Julia Robertson Math Festival. This is one of the famous math festival that you have a 20 station and kid come with their parent. And another national math festival I participated is the one in Washington, DC. That was every 3 years happening. So I decided to go, and the organizer invited me to do it. So surprisingly, not surprisingly, Islamic geometric pattern activity, as you see in this picture, get a lot of attention because it's beautiful, it's art, and it's math, and people really like it. Then after I did this kind of short workshop or short activity with kids, I decided to go further. And then I applied for a program in New York. It's 1 month. You spend 1 month with a 7th grader from New York, and you are doing math every day for 5 hours. The kids stay in dorms, so for the entire month they stay with us. And these kids are underserved student, underprivileged student, which is mean basically they came from either poor family or they are from minority, like a Muslim or a Chinese or Black people. So I'm hoping soon in Kurdistan we can see more camp like that. And this was all free for kids. So I created a course there, and I call it Islamic Geometric Pattern. And for entire 2 weeks, I was talking about math with these kids, and they really love it. And if you look at the picture here, they are playing with a tile after we having some mathematical discussion. Finally, I have been also giving some talk in JMN and math phase related to Islamic geometric pattern. And recently, with another art professor in my college, we created the entire course. We call it Islamic geometric pattern, that we both looking at this topic in a two different perspectives, me from mathematical view and he from artistic view. So quickly, usually this is good for non-Muslim people, but I think it's valuable for Muslim people. Why Islamic geometric pattern? Why this came true? Well, because Islamic work have been seen a very fast expansion in a short amount of time. And while this expansion happened, you see a lot of other culture and civilization emerged into Islamic world, like a Persian, like a South African, and so on. And even if you're thinking about part of Europe. So all these culture, when came into Islamic world, they also, it's not just Muslim, it's not just like Islam give them the religion, but also they are contributing to Islamic world by bringing some part of their culture. And one of the surprising effect on the on this culture into Islamic is they also bring a lot of art and math into it. And one of them will be affecting Islamic geometric pattern. So without this expansion, without this integration of this civilization with Muslim world, this kind of thing not happen. Actually, in Western, when we are talking about Islamic geometric patterns, sometimes we saw people from Iran or people from Morocco, they get mad. They say, this is not Islamic work. This is a Persian art. Or if you are talking about the Morocco, they say, this is from Morocco, this is not. And maybe they are correct in some way, but now everyone know about Islamic geometric pattern because that's what's common and universal in all those locations. So what do you mean by Islamic geometric pattern? Let's understand that one. So basically, Islamic geometric pattern is very beautiful geometric pattern that have certain kind of characteristic that distinguish from other geometric patterns. So we have a lot of geometric pattern from a different other culture. Of course, we don't have Christianity geometric pattern, but we have a Chinese geometric pattern. And if you look at those, you know which one is Islamic and which one not Islamic. Some of the common distinguish between Islamic geometric and non-Islamic. In Islamic, you most likely you have a start like this one. So hopefully I can erase my see. Okay, how can I erase this? Okay, now it's good. So another thing I want to talk about it related Islamic, so when Islamic geometric world expanded, you creating a lot of mosques and holy places. So you want to decorate it. So how do you decorate it? Well, historians say that in Islam you cannot have a human and animal in holy places like mosque. So they decided to come up with the idea. And one idea was, what about geometric pattern? And that was good because in that time also, the idea of creating Islamic geometric pattern give a chance for a Muslim scholar to translate other textbook in geometry that influence this kind of pattern. So a better question to ask, in general, what do you mean by Islamic art? So Islamic art divide into three categories. I mean, all of you seen this, but I just want to repeat it here. One of them calligraphic and floral, and the final one is geometric. We are only interested in geometric one. But in many buildings, you can see these kind of three form of art integrating into each other. Actually, there is a lot of relation between calligraphic and geometric. And sometimes when you have in geometric one, you will decorate it using floral. So one question is this, when you creating any form of art or drawing, the question, how do you creating those art or what tool you are using it? Well, the answer is simple. The tool you are using for Islamic geometric pattern is only ruler or straight edge and compass. this picture is drawn by my friend, colleague David, the art professor. So if you look at this picture, you see two tools, compass and straightedge. And because this is crucial, because in mathematically, not every shape can be drawn with these tools. So that's why historians, when they find certain kind of pattern is not possible, they question how they create it. Now, there is a, so for almost 10th century or more than that, Muslim around the world have been created Islamic geometric pattern during history. One question no one knows for fully to answer it is how, what method they created, or what is the mathematical way to creating all this complex and complicated one. Everyone come up with a theory, but no one know what is the exact method to creating these pattern. So that's why a lot of historians and researchers came up with methodology. And actually in 2016, even someone else come up with another methodology. And whenever one say that this is the way they created in ancient time, some people get mad and so on. So there is no definite answer how, what is the methodology to creating this pattern. But I will mention the three famous one here. The first method to creating Islamic geometric pattern, and we have some historical evidence, is called grid method, and this is very simple. The second one is called point joining technique. This is a method that people love, and people in Instagram, all, if you go to Instagram, checking IGP, you see this method of Islamic geometric pattern. People do it. Artistic people do it because it's beautiful. The third one, polygon technique. Polygon technique is the one that mathematician and computer science love because you can create unlimited type of Islamic geometric pattern. So I'm trying to briefly talking about this, but so for a grid, what you do is you have in a simple grid like isometric or orthogonal, and from there you're trying to trace the pattern that you want. So it's more about trial and error. For example, this is isometric grid that everyone know, Muslim know, because I'm sure they get it from Greek and other people. So this is nothing new. Muslim already know, and they inherited from other culture. So this is isometric Greek, and then you can try to create a pattern like this one. And this is Islamic geometric pattern. Now, after you create the pattern, what you do, you remove the grid, and then the geometric pattern appear. This is one of the technically considered simple or medium complexity Islamic geometric pattern. So, and if I give you this pattern and I ask you to create it, it's really hard to do it. But if you think about how they do it, using the grid will be easier. Now let's go to the second one. This one, again, this is isometric grid, same thing. And here we go, the second pattern emerge. So the beauty of this kind of method, you can do more than one and very easy. Actually, I have been done this with even kid in school because it's simple. You don't have to use in compass, especially in US. We are afraid from parents suing us. This is the third one, and that one is my favorite because this have a 3-fold rotation and so on. And now we have all the 3 patterns from the same grid. So one grid, you have 3 different patterns. Now, another kind of grid they have been used and historically is evident is called orthogonal grid. This is orthogonal grid. This is one of the very famous Islamic geometric pattern and one of my favorite. I don't know, somewhere in home I have it. And you look at it, you have an orthogonal grid and you can just trace the pattern. I did this with my student in classes and the floor was basically square. So I say, wait a minute, we can have a tape. We call this duct tape. So in US, I don't know what we call in Kurdistan. And we were able to do it and we stay for a while. This pattern is from Spain and from Cordoba, which is very, very famous for Islamic geometric pattern. And there is a place there called al-hamra, which is al-hamra, which is mean red, sur, and in that places it's called Mecca of group theory. So if you are algebraist or if you love groups, you must go to there because it's considered as the Mecca of these people. So this pattern surprisingly appeared not only in Spain, in other places. It appeared in Turkey, it appeared in Spain, it appeared in Morocco. I mean, I just want you to, for a second, imagine how these locations are far from each other, but you have the same pattern in a different format, in different shape. And this is telling you how Muslim scholar or artists were advanced in that time. Okay, so let's talk about the second method quickly. The second method is very straightforward. You're starting with a circle, you divide it into equal pieces, and from there you're trying to create more line, and in the end you're trying to find a pattern you like. So everything except so this is this step, this one, this is called all construction line. And after you finish in this one, then the red one, you want to keep those line, and that will be your pattern. And in the end, this one will be your pattern, and then you're removing the construction line, the line in behind, and then you color it, this kind of pattern emerge. So this is what people love now, what people doing in Instagram, point joint construction. This is my friend did it just using, and you have the same kind of construction line, the line behind the pattern, and from there different kind of pattern emerge. This is not very flexible. It's still nice, but it's not very good. And some of them is not Islamic, so it doesn't have to be Islamic. Same can happen. Now, let's go to the one that we all love, polygon method. This is a kind of the champion of the method. So what is happening in polygon method? Let me just go to do this one. You starting with one of the known tessellation, existing tessellation, like this one is called this tessellation called 4, 8. So you're starting with a vertex and you're trying to see what is the neighbor of that vertex will be. So for example, 4, 8, 8. So this is called 4, 8, 8. I cannot draw very good. Sorry for that. So 4, the square is 4, 8 is octagon, another octagon. Yeah, that will be. So this kind of tessellation called 8, 4, 4, 8, 4, 8, 8. Anyone in tessellation, anyone take a tessellation class, understand this is how we name tessellation. So now what you're doing, you are dividing the center of every vertices, okay, and then from there you're creating a line. You extend this line based on the angle between the original one and the existing line. For example, this one may be 45. And then those lines, when extended, it intersecting each other, and in the end, you're trying to keep certain one. So this is not Islamic, and this is you are going here to become Islamic. And just see how the transition go. This line was come from those lines that you created here. This is a polygon. So again, this one is just a normal tessellation. Everyone know it. Now here is very famous kind of tessellation. We call it remisicular uniform, and each one of them have a name. Again, 3, 6, 3, 6 mean if you pick any vertex here, you look at there is a 3 here, there is a 6, 3, 6. This is how we name this kind of tiling. This is Archimedean tiling, and this is very old. So now some historians say that the Muslim used these to creating a very sophisticating the geometric art, Islamic geometric art using these. So they already built on what existed. They don't came from void. So here's the idea. So when you have a triangle, you're starting from midpoint, and then you making bunch of line, and when those lines intersect, you are stopped. And those black one, that's in the end will be remain, and that will be contribute your final Islamic geometric pattern. So look at this one. this is one of the tiling we have. The name is very long, and if you look at it, there is a two-part, 1, 2, because you have two different vertices with different names. So for example, this one will be 3, 4, 6, 4, 3, 4, this one. And there is another one, this one, look at this, will be 3, 3, 4, 3, 4. That's the one. So you maybe have a tiling that have a different. So now this is non-Islamic, okay? Muslim doesn't have anything to do. Muslim doesn't found this. But look how they use this to create this beautiful pattern. This one is Islamic. And this is how they start doing it. They started with a midpoint. They created a bunch of line. The line is based on angle. So this is one example. And there is an app. I don't have a time. Otherwise, you can experiment with it. This is another pattern created similar to the same method. Okay, so today class is about symmetry, and this is the most interesting one. So let's talk about quickly. So this is a slide made by my friend when talking about symmetry. To them, it's something static. But for us mathematicians, symmetry means movement. So whenever you're speaking about symmetry, it's basically you apply transformation. And if the transformation result in the shape doesn't change, then you say, oh, this shape is symmetric, or this transformation is symmetry. And the most famous transformation we have that result in symmetry, not all of them, is rotation, reflection, translation, and glide. So I need to be specific here. So if you have a finite shape, let's like square, you cannot move it and you say my shape is symmetric. This is the translation and glide reflection only happen when you have infinite shape, or you have the pattern. Okay, so that's why in school we don't learn about these two kind of transformation as symmetry. So the main type of that symmetry we all know that is reflection, rotation, translation, and glide. Just refreshing some of your mind, you already know this, but if you have a square, then you have a type of symmetry. 4 of them are related to rotation, and the other 4 it's related to transformation. So this is a website. I actually built it for that, but I don't know why my pen is active. I don't know how to deactivate it, but yeah, this website is interactive, so I can't play with it, but there is a, okay, let's see if I can find it. I don't know. Okay. Anyway, so there is a lot of things going on here. I wish I could do it, but let's forget. Okay, so this is a Chalet group table. So basically a multiplication table for group. Anyone take it abstract algebra? Know about this. Okay, not this. Yeah, so this is a website I created. You can play with this Chalet group or symmetry group of 4. So there's nothing is related to Islamic here, but just wanted to remind you. Now, this is the one that we want to spend more time in it. Symmetry, symmetry of wallpaper group. So till now we talked about what symmetry of square, right? And square is a finite shape. It doesn't expand. It doesn't repeat infinity many in all the direction, right? So we want to talk about a geometric pattern that it expand everywhere in the 2D. And this kind of pattern we'll be calling basically wallpaper group. And we are seeing this pattern are expand in every direction. And if you look at this pattern, this 3 pattern, everyone came from a different location. This one is from China, Tahiti, and Assyria. I believe this should be Neva, maybe Nino. I'm not sure. This is from our Mosul or not. Anyway, wallpaper group, which we will talk about soon. Yeah, wallpaper group is a 2-dimensional repeated pattern in 2 dimensions. These are all examples. So you're assuming this pattern are extended infinitely. So let's agree on that. So symmetry of wallpaper group. So if you have a wallpaper group, which is basically a 2-dimensional repeated pattern, then you have the possibility you have 4 types of symmetry. One of them will be translation. All of them have a translation. Now rotation. Not all of them have a rotation, but if you have a rotation, the rotation will be of degree 2, 3, 4, and 6, which is mean if you, some of them, if you rotate by 180, the shape, the pattern still will be similar, and same for 3 and 4. But not all of them they have. The other one, the other type of symmetry we might make ABC called reflection, and final one glide reflection. And this one is a little unique, so you don't see him too much. Little history here. Okay, so in 2 different persons independently, they were able to classify wallpaper group based on the symmetry they possess, and they found that there is no more than 17 possible way. So any wallpaper group you find should be fall into one of these. Okay, so this one. Okay. Oh, I found it. That's my problem. That one. I don't need this. Now I figured it out. Okay, so this guy was Fedorov was Russian, I believe, and Poila is very famous. 1924 is mathematician, Hungarian mathematician. They found wallpaper group independently, and they found there is no more than 17 possible way. Usually, some people to prove there is only 17 type of wallpaper group, you need more math. I mean, usually in abstract algebra they don't teach that, but some graduate school maybe they do it. So then they name it. Then this kind of name is based on Fedorov. Fedorov called this name P1, P2, PM, and CM. And again, these are all the name. I don't want to go over it. I try to show you some of these patterns. So there is a very famous website. It's called Tile Insert, and that Tile Insert have a lot of geometric pattern, and most of them are Islamic geometric pattern. What did they found? What did they found that? And those patterns they have mostly come from real world, come from somewhere from the world, and somewhere from Muslim world, for example. They found out P4M. This is a type of pattern that is dominating the kind of pattern appear in architecture and in nature in general. After that, P6M and CM and so on. So any pattern in every 2 pattern, you will in every 2 wallpaper pattern you will see the probability that one of them will be P4M is very high. Now let me show you this. What does this mean? What P4 mean? Well, P4 mean a wallpaper group that you have a 2 center of rotation. One of them, the order 2, which is mean 120, and the other one is order what? Is order 4, which is mean 90. I believe this guy, let's see if I can do it. I think this guy is order 2, order 4, because if you rotate this guy will become here and so on. Now, where is order 2? I don't know. I want to say this one, but maybe I'm wrong. Or maybe this one. So yeah, other than rotation, what do you have? You have a reflection, glide reflection, and translation. Now, let me show you this one. This is very cool. So look at this pattern, okay? If you reflect it across this line, okay? So that this shape will become here, right? Now, if you translate this shape, it will be matched here. This is what we call in by glide reflection. So basically, if you just reflect, it doesn't fall into area. You need to reflect it and then translate it. So, okay, now if you want a little math, so let's talk a little math here. This is a simpler example for P4M. P4M, this is the one that is very famous everywhere. You see it in restaurant, in mosque, in other places. So if you look at this part called unit, basic unit, which is mean if you have a copy of this guy and you just copy it and paste it, just move it, just translate it, no rotation, no reflection, nothing. Just do copy this, copy it, then you should be able to create the entire plane. So that's mean this part will be called unit, basic unit. Now, this part called fundamental region. Fundamental region, you are allowed to use every possible symmetry you have. If you're using fundamental region and symmetry of the pattern, you should be able to construct everything here. For example, let's say starting, if you have this one, if you reflect it across this line, then this go here, right? And so on, and this one go here. Now, if you want to rotate, we have a rotation. If you rotate this guy by 90 degree, you get this one. Hopefully. Oh, no, you don't get that one. Maybe you get. Maybe that's not the right order. So this way is writing P4M. This is if you take in abstract algebra, there is a way to write element of the group using generator, and this is a P4M generator. The P4M, the generator for this one is T1, T2, R, and S, where T1, T2 are translation, moving this way and this way. And if you have only these two, this is T1 and this is T2, then you should be able to copy it in any other direction because they are a vector. So this is a T1, T2, S is reflection, R is rotation by 90 degree. And that's why R power 4 is equal to E, which is identity. So yeah. Now let's talk about the second one. The second most popular geometric pattern is called P6M. P6M, if you look at this guy, you see that the center of rotation of this one is 60, because if you rotate this guy, this one come here, this one come here, and so on. And actually you have a hexagon, right? This is a hexagon, and I can go a little more crazy here, and you see that, oh, this is look like fundamental region, and this the entire thing will be unit. So this is Islamic geometric pattern, and very kind, beautiful, but a little complicated. So let me show you another one. Yeah, this is non-Islamic, but it's very simple. So what is the generated group of this one? Will consist of this guy, two translation. So let's say pick this one and maybe this one. Hopefully this is create everything. And then you I'm not sure this one, but let's pick it. And the other thing you have this kind of translation are commute. And the degree of rotation is 6. That means if you rotate the pattern 6 by degree 60, and after 6 times you go back to original. Again, the Islamic one is more sophisticated, more beautiful. The question, how they created this one? Okay, now here is another pattern. This one is kind more complicated, called CM. In this one, you don't have rotation. You have a rotation. Yeah, you have a rotation over 2. So no more rotation of the degree. You don't have a rotation of degree 4 or 6. And you have a translation. Again, every wallpaper group have a translation. So because that's a basic thing, you need to be able to copy, move it. So now let's go to look at the simple example. Maybe this one, it's not exactly, maybe. Okay, so let's look at this one. So what is a repeated one? Repeated ones look like this guy. This is look like a repeated one. And what is repeated? This is a repeated unit. What about what is fundamental region? Fundamental region, I want to say this, but maybe not. Okay. This can be, when you reflect it, you get this back. When you when you reflect again, no, you don't get, when you rotate it, maybe you get that one. I believe so. Yeah, when you rotate this one. So what about the generator for this one? This one mean T1, T2, and S. S is reflection. So you don't have too much reflection. You don't have too many symmetry here. P6 is also clear from the name, you have a order of you have a rotation by 60, which is result in P6. So basically, you have one of the center of rotation have a degree 6. So this pattern is also belong to Islamic geometric pattern and is found in Alhambra. That pattern made 500, 600 years ago, and also this is built into the wall, most of them. Quickly looking at the simpler example, again you have a translation, two translation and only rotation, and rotation by, this look like this is mistake. This should not be a reflection, because even here you don't have a reflection. Okay, let's go more. PMM. This one you have a two reflection that they are perpendicular. That doesn't mean every perpendicular should be every reflection should need to be perpendicular, but in this case in PMM, which is not very common. I mean, you don't see this one in everyday life, and you have two translation. All of them have two translation, and then you have a two reflection, and the two reflection will be perpendicular in each other's. Okay. Oh, this one of my favorite that even I have been printing them. So this is called Yemeni. Can someone tell me what? Do you see any word here? Arabic word? Let's quiz the audience.
I think no.
I'll give you a hint. This is made in Yemen.
Okay.
So this is
just for the audience. You can write in a chat.
Yes. This is one of the, maybe the second. Yes. Let me give a hint. This is the second holy person in Islam. Yes. Yes, Kak Chavez, please. Chavez, Kak Chavez, yes. I think someone. Yes, please.
Hello. I think it's written Ali.
Yes, that's it. This is Ali.
Yeah, thank you.
Thank you to you. So this is the four Ali interlocate to each others. This pattern have been studied a lot, and there is a paper about it. If anyone interested, I'll try to find it. This is called Yemeni square. Yemeni square, and you guess why? You know why it's called Yemeni? Because it's found. Yemeni should be maybe NI. Yemeni square. Square. This is very famous and very beautiful, and actually there is a mathematical paper written about this kind of pattern. And if you are in love with math and you like also doing programming, this is a good way to play with it. Okay, in this one you have two translation and one rotation, and the rotation, it's not hidden, should be 90 degrees. Okay, so another pattern that is beautiful, and something else too. I want you to pay attention to this. Do you see this one? Only one shape exists here, right? So if you have one copy of this shape, then you can cover the entire plane. We call it motif, M-O-T-I-F. Some Islamic geometric patterns are more complex. Some of them are simpler. This one is very simple technically. You only have one motif, while this one also have one motif. So another thing to pay attention to it. This one you have a two translation, one rotation, and one reflection. Okay. Right. There's something cool I want to show you. Now this is a beautiful this. Question: how many times you have been in Erbil visiting Muzaffariya Minaret and thinking about Islamic geometric pattern? I have been working around that area for years. I never been looking at the minaret in this way. When I came to US, I read a book and it talked about this pattern from Erbil, and I said, wait a minute, are you kidding me? Let me check it. Where? And they say Muzaffariya Minaret. And I told myself, I feel bad because I need to cross the river, cross the ocean, I mean, by airplane, and come to US and reading book to realize there's a this beauty in my country and my city, and I could not see it. So this is pattern from Erbil, and you will see in a lot of Islamic geometric textbook. Another pattern, this one is more beautiful. Again, this pattern P4G is also from Erbil. It's from Minarä, same places. And sadly, this kind of pattern is not preserved very well. So maybe when you go, you don't see it. And I'm hoping maybe some of you know someone from government. Maybe in future we will try to creating this pattern again. And look at, yeah, this is it. And I want to show you. Okay, now let's look at them now. So those pattern is either there or there. And guess what? As a bonus, there's a fourth pattern here too. 1, 2, 3, 4. I mean, all this pattern in one building, and this is made in 12th century. So this place is many mathematicians, many people in our Islamic geometry work want to visit and take a picture with it, believe me. So I'm hoping one day we can make a tour to show this to people about the beauty of math. So here is a textbook. Here is a paper. I picked this image from that paper. The guy is a professor in Liverpool. So, and you see that. And here's this is the picture I took. I found it from online. It looked like this is one of the pattern from the minarät. And this is a picture of the minarät too. And this is another one. So let's call it, this is 1, this is 2. So I'm going back to telling you 1 and 2. So this is 1, this is 2. But sadly, it's not very clear. So let's hope, let's wish some people, they appreciate this kind of pattern, have a big, and look at this one, another pattern here too, okay? So it's not only those, we have more. So we have a lot of Islamic geometric pattern in our country, in our city, in our region. I think we should take care of it. Now, what I found is this. There was a guy, German, I believe, came to Kurdistan and came to Erbil specifically, or Iraq in 1920, and trying to study the architecture and architecture placed on this area. And guess what? He write about Erbil, and more specifically, he don't care about anything else in Erbil. He care about Minarä. And this is a place, this is what he did. He drew in that. And sadly, this text is in German. And the text is available online. You can look at it. You can see it. And here's the picture of them now. The guy did it and show you 4 different patterns. The one I talk about it. But the one I'm interested in is here and there. Okay, so in US, we are lucky to have a very diverse people. I am living in an area that 40 minutes far from those mosques. This mosque is a Turkish mosque and made by government. And I took my student to there, and we found like more than 20 different, maybe more than 20 different Islamic geometric pattern. And they would really appreciate, people doesn't know anything about Islam, and they have sometimes negative thing about Islam. When you share them something non-political, they appreciate it. And this is another thing I want to point out to it. So there is a bunch of museum in Washington, D.C., which I am located area, close to it. In this location, there was an exhibition called Amish quilt, or the quilt of Amish, and the name was pattern. And so we looked at those, and it was there was a lot of pattern here that also, it's not Islamic, but they are wallpaper group. So I'm wondering if one day people from our country also studying this kind of quilt. I know back home when there was not too much choices, my mom make something called, we call it lefa. I don't know in Erbil, what do you call? But in all those lefa, there is certain kind of geometric pattern or symmetry. So I wish some student will be eventually studying those kind of things. Another thing, we students do it on the wall, on the floor. And finally, I try to create a tool app to exploring this kind. So if you don't have a book, you can try it. I can share it later. And finally, this is it. Finally, if you want something interesting, you want to play with it. So here's sharing you this website. So I don't know, where should I share? Okay, how can I see a chat? Okay, I think I see a chat. Here is the link. Okay, chat is turned off. Okay, maybe I cannot do it. So I built this website, and if you click on the flowchart, you can see how we classify wallpaper group. Okay, the first question you ask, if this wallpaper group have 6-fold rotation, if I rotate it by 60 degrees in certain point, the pattern will be still the same. If yes, then you come here and so on. And after you answering all this question, I mean, not all the question related to your pattern, then you should be able to figure out what kind of wallpaper group you have. So I want to invite you to also try some of the pattern here. Also, I want you to, when you go in the market or you're going to bazaar or wherever places you see some beautiful pattern, you can take a picture and study it. Because the app is have a feature that you can upload it or you can browse it. Now, if you browse it, there is almost like a 2000 pattern here. So you see a pattern and then they ask you a question. Do you have a rotational symmetry? Of course they don't have. Do you have a 3-fold? I don't believe. Do you have a 90 degree? Yes, I see you have. Any reflection? Yes. Does all center for center, right? Say that is the center of reflection line fall into center of rotation. I don't know. So let's do this. This is center of rotation. This is center of rotation, I believe. I don't know. Let's pretend. If I'm wrong, tell me wrong. I don't know this one. Yeah, I believe so because this is a reflection. This is a reflection. This is a reflection. No, that's not reflection. No, that's not reflection. So let's say yes. Let's say I say that it's P4M, but sadly it's not P4M. It's P4G. So it looks like the last question I was wrong. And then after that, you can click on it. You'll learn about this pattern more. I take you to the original website that I took those pictures from it. It's telling you where this Islamic geometric pattern belong and give you more idea. And if you are lucky enough, maybe they have a picture. So let's click on it. And this is a picture of it. And this is exists. So maybe if you find certain kind of pattern, and then you can even submit it to this kind of nice people. So also, if you want to upload it, so you can upload. Yeah, so let's do this one. This is the one from Arabic. I don't know exactly, but let's say that they ask you a question. Do you have a 60 degree? No. Do you have a 3-fold? No. 19, yes. Reflection, yes. Yes. So this say P4M, which maybe. So I think this is for me. I don't know. I mean, I can go longer, but I don't know how much time I have.
Time is close to up.
Okay, I think
You may have 2 minutes, Dr. Okay.
Okay, so yeah, so how do I want to close up this? My goal in this talk is I could come talking about my area of research, but I wanted to pick this topic because of related to a humanities side of math. Math is not supposed to be only about equation. And I think we have a lot of people in our country, they don't like math because the way they math taught. And I think there is a different way to introduce our student, our people into math, and especially something more relevant. Why we in textbook we talking about something from Saudi Arabia or something from United States? Why we don't show them this kind of pattern where they can see it daily? So I am hoping many people and some young people, even there is many people making business out of this. So if you are young, if you want explore new direction, I think there is a lot of room for you to grow and create this. So even for fun, if someday you are tired, you can just try and bring compass and ruler and some color to it. Before I know Islamic geometric pattern, I never have any art supply, but after that, I have a tons of watercolor, name it, and I enjoy it. So math can be fun, and let's tell people that. So this is.
Thank you so much, Dr. Rabin. You share so several new information, especially we mentioned it, Erbil. And we all thank Dr. Rabin for the nice presentation. I'm sure he opened so many doors to new idea. Now, if there is any question, please raise your hand and Dr. Rabin is going to answer you. But if you didn't enter your full name, please rename it, then raise your hand. Okay. Is there any question? I think, okay. Kak Abu Bakr, yes, please.
He's muted.
Now you can speak. Okay.
Hi, good afternoon, Dr. Rabin. Thank you so much. That was a very interesting topic. For people like me, we came from civil engineering or maybe mechanical engineering. Often we don't see this kind of pattern. We don't look at stuff like that. We're more concerned about engineering and stuff like that. I did quite enjoy it to know such a thing even exists, by the way. Thank you.
Thank you too.
My only question is, you keep mentioning Islamic patterns. Is this a reason for that, or we call it because it just happened to be in places which happen to be Islamic rule? We call them that.
I really love that. And me living in US, and you know, there is an Islamophobia in this country. There's a pattern, people come and their kids love it, and then they see the name, they get a little suspicious, and they can ask me, and people in this country are very honest. They don't like you, they come, maybe they tell you don't like, and they told me why we call it Islamic geometric pattern, why we don't have a Christian. The only reason we call it Islamic geometric pattern is because this kind of drawing developed separate in Islamic world. Let me tell you something. There is a lot of location in when Turkish invaded Bulgaria, the church turned to mosque, and then they created a lot of Islamic geometric pattern there. Then when they left, they turned back to church, but they don't destroy those Islamic geometric patterns. So they say this is the Islamic geometric pattern in church, just because made by Muslim artisan and have a Islamic flavor. But again, Muslim artisan took this from non-Muslim and they built on it.
So basically, it just happened for people who make that. It just happened for them to be Muslim at that time.
Exactly, and that's why
it doesn't have kind of special knowledge comes from a specific Islam root. It just for people happen to be Muslim.
Okay,
yeah?
now, yes. Now you open it another door. Let me tell you this. This is my opinion. So in people in doing in West, they like to a lot of spirituality. Okay, so people ask me when I'm giving the talk in museum, they tell me, oh, what is the spiritual aspect of this? And I say, no, nothing. That I don't see it. But I can show you a textbook. Tell me Islamic geometric pattern have spirituality. I say how? I say, look at it. You see a star in the center. This is God, and everything come from it. And I say, okay, if you take this one, let me show you a pattern. There is no star. What are you talking about, right? So the good thing is this: if people believe in it, I'm fine with it. Anything make it Islamic geometric pattern more popular, I am full for it. Yes,
Dr. Rabin, thank you so much. Thank you so much. And also, I would like to thanks everyone who was involved in making this seminar. Thank you so much.
Thank you so much, Mr. Bakir. Okay, any more question? Kagrawa, yes, please.
Brilliant. Thank you very much. That was very informative, and I deeply appreciate your time, all of you. So I know when you go back to history, especially the Islamic world or otherwise, you don't see a formal language as we are practicing today, especially for the semi-periodic or quasi-periodic shapes and patterns you showed us, especially from places like Hamra. But could you, if you had time, or trace the origins of aperiodic tilings to those places, or they were just merely artistic, or they did it for aesthetic, or they didn't know exactly what they were doing in terms of today's formal language?
This is a good question. I mean, so here is the thing. Did you finish your question, or sorry, I stopped with you?
Yeah, I mean, if I'm able to communicate the question, I think I've lived.
Okay.
I finished my question.
Okay, so what happened is this. So there is Al-Hamra, right? In Hamra, built 600 years ago, something like that. And then after that, many researchers went to Al-Hamra, and then they were able to find example of this 17 type of Islamic geometric pattern. Then some people jump and say, Muslim know about wallpaper group. They want to say that because it exists. And there is this kind of discussion that some people want to take it too far, Islamic geometric pattern, and I'm not one of those people. I think human by nature love symmetry. Human are curious. Sometimes we are building things, and then later mathematician comes say, "Oh, what you did is called that." Fascinating. So when the Muslim artisan created all those different pattern, complex patterns, they don't think about wallpaper group. They just thought about make the decoration of these places much better. And here is a funny thing. I don't know if this is my theory or not. One way Islamic geometric pattern advanced is this. There was a many leader in Muslim Islamic world. They have a different building, and each people competing with each other. One way to compete is decorating their building with better, different pattern. And this is a kind expand or this. So I don't know if I answered your question, but I think Muslim use it existing geometry to build upon it more advanced pattern.
Yeah, I believe the answer is clear. Well, the only other way to go about it, I suppose, is to be able to formalize a language for all of those patterns and see if you can find traces, if such aperiodic tiling was even possible to the imagination. Because I don't think purely mathematicians did this. It must have been artists.
No. Let me be clear. This is not only work of mathematician at all. And there is a joke in some book. Some people know this by head. They say some of these patterns people know by it. It's very complex. They know it by head. And there is a joke say that one of the people from West 200 years ago, 100 years ago, came to this area and they saw very beautiful pattern. And when they asked the dad, say, how do you do this? And say, oh, my son do it. And say, can you show me how he do it? He say, no, he do it by just the pattern in his head. And then the guy say, wow, your kids should be genius. I say, no, my son is not genius. The other one is genius. Say, how? We say that they have a two pattern in his head. He can draw it. So it was purely artistic. But there is a proof certain kind of pattern cannot be made without mathematical background. That's why there is a theory, there is a mathematical textbook written for artisan in that time. Some people believe this book doesn't exist. There is a name for it, but many people think that this was happened. But to me, mathematician and artisan go hand by hand, helping each other. This is the way, at least.
Yeah, well, thank you so much. That was really enlightening. One more thing, if I just may add, I believe it's very hard to add any of these or trace back these historical aspects of it if they knew or they didn't know, because we simply don't have the fossil for it. But I believe we have enough material to be able to create some sort of historical narrative from it. And from that historical narrative, that will be just basically try to relate all of that historical artifacts to today's modern reading, because as a physicist, I could tell you there are some hints of non-Euclidean geometry in that part of the world. But how am I going to prove this as a physicist? Well, by looking into it and develop some formal language for it. But thank you so much. That was
Thank you
great.
to you, Kakara. Very good.
Thank you so much, Gagra, for your valuable question. Okay, because time's up, we thank each of you, especially Dr. ڕێبین, for his time. Okay, dear participants, we thank each of you for your time and valuable contribution today. Have a great time. See you all next seminar. Thank you so much, Dr. ڕێبین. You showed us so many things. Thank you.
Thank you too.
Thank you, Dr. ڕێبین, for this insightful, let's say, geometry, Islamic geometry. We really appreciate your inputs in this talk. And then we can see not all mathematicians, you see physicists, also engineers are also interested in this talk, hoping to have more, let's say, talk in the future. I was in Alhambra, as you said. Wow. We are all surrounded by this natures or this geometry, but we haven't seen it, or no one like direct us to see all this beauty. But once I was in Alhambra, Cordoba, and then Seville last time, I was really amazed by all these wallpapers. And then they kind of making putting in a trick. How do you find all 17 wallpapers in the Alhambra mosque? So what was really amazing that time. Yeah. So yeah, I mean, following all this your activity, and then also seeing all, I was even mentioning you to the professors, like we have a friend of mine like doing all this stuff. So it is, what you do is really an amazing job. So I was just wondering one more question before we closing up. So this a periodic monotile. I mean, it was, I believe, last year they kind of come up with this.
Yes.
Yeah, Einstein tile, the hat, whatever. Do you have any? Can you maybe for the people?
Well, honestly, I know the people who involved in it, and I don't have too many things about it, but I know a little about the guy who, one of the author. So, and this is beautiful, and I want to tell to a lot of people. One of the leader in computer aspect of Islamic geometric pattern is called Craig Kaplan. Craig Kaplan is one of the author of the Einstein tile, and he is also director of, I believe, in a very famous conference called Bridge Math, that is interdisciplinary conference between math and other things. Honestly, a couple days ago I read quickly, but I don't have too much idea. So sadly, no. Even I have a 3D print of it, I don't have too much. What is it?
Yeah, no.
I'm mostly like interested in the repeated one that will make a wallpaper group, and sadly, that one Einstein tile doesn't fall into it. It's non-periodic tile.
Yeah, it's a periodic. All right. Thanks a lot. Thank you, Dr. Ṛێبین.
Thank you too.
Really appreciate your time. Yeah, really appreciate your time. Take care.
Very welcome.